recording. And again, I can never remember it, and I very often run into this problem that I forget to assign the result back to the variable, which is like, this entire section here produces brand new big decimal with a new value, and you have to reassign it back. It's not done in place. It's done as a copy. This method call makes a copy, and I need to capture that copy. So then I did what I intended to do. So let's quickly discuss the rounding modes. For example, a rounding mode half up does this. You have a fraction, right? So let me make it a little bigger, right? So you have a fraction like 4.5. If you are rounding it to like, the whole number, obviously the rounding up takes place. If it's less than half, 1 point less than half, like 1.1, it gets rounded down. Now, this interesting mode that we're essentially trying to discuss here today is the rounding mode that is called a rounding half even. It will, the behavior changes. The behavior changes. By the way, here's the curious set scale example with just 0 of the fractional numbers, right? Which makes sense that 0, specifying 0 at this precision parameter that we pass to this set scale call specifies that we want precision 0. We don't want any fractional parts at all. We want to round to the whole number. So in this case, 2.5 becomes 2, surprise, because we were expecting that to be 3, based on the knowledge that we had before. And 7.5 rounds to 8. Well, you say, how could this possibly be? Well, it's because what it does is it says, I need to round to this level of precision. In our case, just a whole number, because the precision 0 was specified. And then if this number is even, I'm rounding down. If this number is odd, then I'm rounding up. Everything else works as expected. 7.1 will be rounded to 7, and 7.8 will be rounded to 8. But this issue with the half is handled, randomly based on the previous digit, which is always available because we're rounding to a certain level. So this is called, I believe, this is called like a U.S. banker rounding. It's another name in the industry. So, and we have this sample here, which basically demonstrates, which is also available through the sample page, but I have a direct link to it. Let's actually try this. Let's try this example. All right. So I will grab it from here inside my main function, right, and copy it. Paste it here so we can quickly discuss and observe what is going on. So I'll just probably destroy what I had to this point and replace it with this. By the way, every time you copy and paste, it really doesn't hurt to go to source and format, right? So that everything is nice and neat to begin with. And since I'm using the scanner to get user input, make the program interactive, of course I need another import, which I'll do by saying refactor. Actually, it's right here, fix imports, right? Fix imports, and it just types in the import statement for me. So now I should be able to compile and run it. This should say correct, by the way. So let's take a look at what's going on. we create a scanner. Then we say then we create a string variable named choice, set it to yes, compare it with yes, and first time entering this loop. And it says enter a floating point value. We will type some value and get it as string. Remember, instead of saying next double, which will give us a double number with that crazy precision, instead we say no, we're going to take literally what they just typed. They just typed this fractional number, for example, a floating point value, and we're going to save it as string. Then we're going to kind of split two ways. First, we will use the double class, and it has this parse double helper method, which takes the string and makes it a double and store it as double. And on the next line, we're going to create another variable, BD value, big decimal value, which takes string and constructs a big decimal object. So now I have stored this text in two containers. One is a primitive data type named value, right? And another one is big decimal object, which stores stuff similar to double, but uses its own little tricks to manage the precision. So then I say, how about this? We take a couple more steps, and we say big decimal half up, set scale two fractional numbers, but use rounding mode half up. On another one, BD half even, set scale using rounding mode half even. Okay, so we're splitting even more. So double, we accepted just a double value, that's fine. Then we say, oh, okay, actually, let's create big decimal, capture a big decimal. Once we have big decimal, we can use set scale, right? So we can set scale for using precision 2 decimal points, and using, in one case, with one copy, using half up. In one case, the other one that we discussed, half even. That we're going to print this nice report displaying all these values. And then we're going to say continue yes, no, and ask the user whether they, if they type Y, then we're going to continue. So let's build this and run it. And in this case, enter a floating point value. So let's try this, 0.111, right? Hit enter. So it says, all right, double value is going to be displayed as was entered. The big decimal first time captures it as the big decimal. Then we're going to show that rounding using half up or half even is exactly the same. Why? Well, because the difference only applies when there's a number 5 at the end of the rounding that is taking place. For example, right? If I say yes, continue on, enter floating point value. Remember, I'm rounding using like 2 decimal points to retain the value. So here, if I type 0.151, something like that, and 2, 3, 4, 5, 6, 7, 8, whatever, I am going to attempt rounding at this level, right? And so this obviously comes back as 1.5 because 1, which this portion of fraction, which is tossed because of the rounding, is simply much less than half at that level, so it gets tossed away. If I continue on in this time, enter something like 0.125, right? And hit enter. The half up rounding gives us 1.13, which is expected. Whereas the rounded using half even method of rounding gives us 112 after the decimal point, And again, arguably, this is U.S. banker attempt to keep the rounding balanced, because by chance there will be, odd numbers in front of, in front of the significant digits that are going to be rounded, and the others that are going to be tossed. And vice versa, there could be odd and even numbers, and each time it's going to go up or down. And so, arguably, this may be a chance for us to use this rounding to keep, approximation of the proximity of error that may occur as a result of different computations within a certain range. Question.
This question is more of a rounding question than it is.
Sure.